Heavenly Father, thank you for this seminar. Help us to understand all that we are going to study. Give us general wisdom to capture all that is going to be taught to us. When we see everything going well, we shall always glorify and glorify you through Jesus Christ our Lord. Amen.
Thank you so much, Luyonza Secondary School, for leading us in an opening prayer. Once again, I want to welcome all those that are joining us. Thank you so much for joining. We are going to continue with this. We're going to have questions. We shall be using the same seminar questions we used last time. So last time we started on a few numbers and we were able to do quite a number of them, and that's where we shall be starting from today. And we shall look at different numbers. Please have your pen, have your calculator, have your book somewhere, such that you can be able to take something, to record something, such that you are ready for the final exams. This one is going to be one of our last seminars. If at all I'm not mistaken, it's going to be our last seminar. And the other thing maybe we shall be only sharing with you, there will be past papers, marking guides, notes, and anything. So it is through this, it is in this seminar that you can ask us anything, any material that you might be needing, anything that you might be lacking, and we get a way on how we can share. But I want to assure you, for math, we have everything that you need. So we shall give you everything for math that you might be needing to see you get a first grade. At the end also, I think this weekend we shall be sharing with you all the unique question papers arranged very well in topics to allow you to make more practice in the different topics. So that is what we shall be doing over the weekend. Once you receive those questions, please start start with the practicing of the questions. I want to welcome everyone that is joining. Thank you so much for joining in the call. And now I think we shall get started. Let me ask, I know we have some people who have really prepared to present, to take us through their presentation. I have already seen we have Arthur, we have Emilia Joy. We had, I don't know if we have Lynette. Lynette, I don't know that you have joined. In case Lynette, you have joined the call, please raise up your hand. In case Luyonza, also you have a question you want to discuss, we shall be really very grateful. Degree SS, in case you have any question you're going to discuss, we shall also be very, very grateful. Lynette, in case you're on the call, raise up your hand such that you may get the rights to be able to share your screen. And any other person that might be having a question to present, please also go on and raise up your hand such that you may be able to get the question. Okay. Emilia Joy, do you want to open us our discussion? Emilia Joy?
Yes, please, Mr. Kazima.
Okay, would you be the one to open up the discussion?
Okay, let me do that.
Okay, thank you.
Good afternoon, everyone. Good afternoon, everyone. I'm going to be sharing with you a number on the topic of probability. So the question said, a fair coin and a fair die are tossed together. Write down the possible outcomes of this experiment. Find that an even number and a head show up. a number greater than 4 shows up. So the first part of this question says that a fair coin and a fair die are tossed together. Write down the possible outcomes of this experiment. That is going to be the first thing we shall do. We shall note that a coin has two sides, that is the head and the tail. A die has 6 sides, each numbered from 1 to 6. So therefore, the possible outcomes of this experiment will be as shown in the table below, in that you could have a head and a number 1 show up, a tail and the number 5, and all those possibilities. So go ahead to answer the other parts of this question. The first part said that find the probability that an even number and a head show up. We shall look at our possible outcomes as we had below, and then we shall keep in mind that even numbers on the die, even numbers that we have on the die, we have the number 2, 4, and 6. And therefore, our possible outcomes in that the probability that the chances that an even number and a head show up will be when the head and the number 2 show up, when the head and the number 4 show up, and when the head and the number 6 show up. The total number of those chances is 3. The total number of chances of this table is 12. Therefore, our probability will be our probability will be 3 out of 12. And then we shall reduce these to get a quarter. We shall continue to part 2 of this question, which says that a number greater than 4 shows up. We shall first have our table of possible chances again. You refer to it again. And then the numbers that are greater than 4 in this dice are 5 and 6. Okay, I've got a question in the chat that I was told good. We'll get the total number of chances 12 when we count the chances from here. This is our first chance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The numbers 1 to 6 that we see here are the numbers on the die. So these are just showing us the figures on the die. And then the head and tail that we're seeing up here are the possibilities of the coin. So the rest of what we have here are the 12 chances, which are the total chances. I'll continue. The numbers on the die that we have that are greater than 4 and 5, that are greater than 4 are 5 and 6. Therefore, our chances will be the head and 5, the tail and 5, the head and 6, and the tail and 6. So the chances that we expect when a number greater than 4 shows up are 0, 4, 4 chances. The total chances, just like we have just counted, will be 12. So we'll get our probability to be 4 out of 12, which will reduce to get a third. I'll continue to part B of this question that said, okay. A certain student school bag contains 4 red pens and 5 blue pens. 2 pens are picked at random from the bag successively without replacement. Determine the probability that Both are of the same color. They are of different colors. The second pen is red. So go ahead to also answer this question. And we shall first analyze the first part. A certain student school bag contains 4 red pens and 5 blue pens. 2 pens are picked at random from the bag successively without replacement. So we are going to draw a tree diagram to answer this part of the question. And we'll first indicate what we have in the bag. Right now in the bag, we have the 4 red pens and the 5 blue pens. So in the case that someone picks a red pen, we will have the probability of picking a red pen equal to the 4 red pens in the bag out of the total number of pens in the bag. When you get 4 plus 5, your answer is 9. So you're going to have 4 out of 9 as your probability of picking a red pen the first time. The results from there, we shall continue. Since they said you pick the pens without replacement. That means that when you pick a red pen, the number of red pens in the bag are going to reduce. So when you remove 1 red pen, you will remain with 3 red pens. Since you have not touched the blue pens, there will remain 5. From there, if a person again picks and they pick a red pen, have your probability of picking a red pen the second time equal to 3, which is the total number of red pens in the bag by the time this person picks the second time, out of 8. Out of 8, which is the total number of pens in the bag right now. So your bag will remain with 2 red pens and 5 blue pens. In the case that this person first picked a red pen and then picked a blue pen, you're going to have the probability of picking a blue pen this time around, the second time after this person has picked a red pen, be 5, which is the total number of which is the number of blue pens in the bag when this person picks a second time, out of 8. Then from there, the remaining pens in the bag that you have your 3 red pens and the 4 blue pens. Okay. So I'll continue to pick even my blue pens now. Now, in the case that this person starts by picking a blue pen, we're going to have the probability of picking a blue pen is equal to 5 out of 9. 5 is the number of blue pens in the bag by the time this person picks, and 9 is the total number of pens in the bag when this person is picking. Therefore, in your bag, you have 4 red pens remaining and 4 blue pens. In the case that this person continues to pen and they pick a blue pen, your probability will be that when this person picks, now we say that this person first picked a blue pen, therefore the remaining blue pens in this bag are 4. The probability of picking a blue pen the second time is going to be 4 out of 8, since 8 is the total number of pens that have remained in the bag. If this person, so therefore what we shall have remaining in the bag will be 4 out of 4 red pens and 3 blue pens. So in the case of this person, instead of after picking the blue pen, they picked a red pen, we shall have the probability be 4 out of 8, since there are 4 red pens in the bag and the total number of pens in the bag is 8. So your bag will remain with 3 red pens and 4 blue pens. So when you're picking from the bag, you must note that when you pick, the first time we pick, when you look at us picking the red pen and the blue pen, when you add these two, you're supposed to get 1 as your answer. In this case, if you add 4 out of 9 plus 5 out of 9, you get 9 out of 9, which is 1. Even in the case here where we are picking from this bag, where we pick a red pen and a blue pen, when you add the 3 out of 8 with the 5 out of 8, you get 8 out of 8, which gives you 1. In the case that you're picking from this bag down here, we look at us picking red pens being 4 out of 8 and the blue pens being 4 out of 8, and the total of this is 8 out of 8, which is also equal to 1. Now, in the chat, someone asked if they say with replacement changing. Therefore, here you have your 4 red pens. You pick, and here instead of having 3, since when you get 1 pen, the number reduces. Instead of having a 3 as we have here, we'll still have a 4. When we look at down here where we reduced our number from 5, and then here we had 4, instead of us having 4 here, we shall still have 5. So I'll continue to go on to answer the next parts of this question. So they say determine the probability that both are of the same color. Here, both pens are of the same color. Now you're going to refer to your tree diagram that you have just drawn. In the case that this person picks 2 pens of the same color, you could have this person picking a red pen first and a red pen second, or they could pick a blue pen first and a blue pen the second time. So therefore, you're going to have the chance of, which will be 4 out of 9. You have the time when they pick the first red pen, which is 4 out of 9, and the time when they pick the second red pen, which is 3 out of 8. The and here in our statement means you're going to multiply these 2 probabilities. The or means you're going to add them. So go, what if they pick blue? If it's blue, you're going to have the 5 out of 9 being multiplied with this 4 out of 8. Therefore, we have our 4 out of 9 times 3 out of 8 plus 5 out of 9 times 4 out of 8. When you work out this bracket, you get 3 out of 18. When you work out this one, you get 5 out of 18. When you add these 2, you get 8 out of 18. Yet, when you reduce the 8 out of 18, you get your probability as 4 out of 9. That is for when you're determining the same color. That means you're going to pick red and red, blue and blue, orange and orange, depending on the colors that they have given you. If they say that determine the probability that they are of different colors, we are still going to go back to our probability tree. So different colors, you could have the probability that this person first picks a red pen, then they pick a blue pen, or they pick a blue pen and then a red pen. They're still different colors. They have not picked the same color. So here our chances, we have the chance of 4 out of 9 being multiplied with 5 out of 8. We also have the chance of 5 out of 9 being multiplied with 4 out of 8. And these ones are added to get the final answer. So you'll have 4 out of 9 times 5 out of 8 plus 5 out of 9 times 4 out of 8. When you work this out, you're going to get your answer as 5 out. When you work out the first bracket, you get 5 out of 18 plus the second bracket, which also gives you 5 out of 18. The total of this is 10 out of 18. When you reduce it, you get your probability as 5 out of 9. We'll go to the last part of this question. We say that determine the probability that the second pen is red. If I'm to say that the second pen is red, we shall first look at our tree diagram. You go back to your tree diagram again. If the second pen is red, means I could pick a red pen first, then a red pen second. My second pen is red. I could pick a blue pen first, then the red pen the second time. still my second pen is red. So it doesn't matter what I pick the first time. What matters is what I pick the second time. And the second time in this case, I should have picked a red pen. So you go ahead to have the 4 out of 9 of where we're having picking a red pen first and a red pen second. So we shall multiply 4 out of 9 with 3 out of 8. We shall then go ahead to multiply 5 out of 9 with 4 out of 8. We will do that. From the first bracket, we'll get our answer as 3 out of 18. And from the second bracket, our answer will be 5 out of 18. When we add this, we'll have 8 out of 18. Our total will therefore be 4 out of 9. That marks the end of this question. So if you have any questions, feel free to raise your hand.
Anyone with a question, please raise up the hand or you can use the chat. Otherwise, we are assuming that now everyone has understood how to do probability. Joy. Okay, Joy, there is that question in the chat.
On the last part, I did multiply the denominators, but I simplified them. If we are to look at this in the case of actually working it out, this 4 can reduce, with 4, you can get 1 if you're to reduce by 4. With the 8 down here, you get 2. So you're going to have 3 times 1 up here to get 3. You're going to have 9 times the 2 to get 18. When you get the 3, that gives you your answer 3 out of 18. The same applies to this side. You're going to reduce this to 4 out of 8 to a half. So you have 5 times 1 and 9 times 2 to give you 5 out of 18. When you add the 3 and 5, you get 8 out of 18. When you reduce it, you get 4 out of 9. Are we together with that? For this last part,
Okay.
someone said we don't understand on the last part. For this last part, I say that the second pen is red. That means what you pick the first time doesn't matter. It doesn't matter. It doesn't matter whether I first pick a blue or whatever pen color they have given me. What matters is what I'm picking the second time. So in this case, the probability will be when I pick a red pen first and then a red pen the second time, which is 4 out of 9 times 3 out of 8. Or when I pick a blue pen first and then a red pen, which is 5 out of 9 times 4 out of 8. When we looked at our tree diagram, that is what we picked on. What really mattered here at this point was this red pen the second time and the red pen here the second time. That's what that basically mattered. But because they want the probability runs from the first time you pick, you're going to consider both. So here we are looking at the journey from blue and then red, and then we're looking at the one from red and then blue. Those are the two chances that you're going to have. Someone talked about when we talk of the same color, I'm going to use this same diagram. So if we are to talk of the same color, that means both times when you're picking a pen of the same color. The color doesn't matter. It just has to be that if the first time I pick red, the second time I've also picked red. If the first time I pick blue, the second time I'm also picking blue. So that's how the same color comes about. If I had used another color like probably black, that means the first time I pick black, the second time I'm also picking black. Are we together on that one? Yes, please, Biguli. Biguli. Biguli, is it okay if you request the people in your background to pass you this on their volume? Because we can't hear you, we are hearing them. Okay, I think that's better. You can continue.
What if we add the probability of red being the last, add the last 3/8 and 4/8?
Okay, I've got your question. So it's simply, you can't use the 3/8 and the 4/8 the last time because the probability runs from when you're picking the first time. That's when everything is being determined. You considering the 3/8 and the 4/8 means you're leaving out something from the start. What did you pick the first time before you got to 4/8? What did you pick? What were your chances the first time before you got to the 3/8? So they want the whole entire chance of you picking a red pen second, that you first pick red and then red, blue and then blue. That's what, blue and then red, sorry about that. And that's what they basically want. Lynette, you have a question? Lynette, do you have a question? Okay, Abby?
I hear me.
I'm sorry to take.
Yes, I can hear you.
Okay, so I'm sorry to take you back, but like, could you please demonstrate again how you construct that tree diagram?
Yes, I do.
Okay, Lynette, could you also ask your question? We didn't hear you.
Could you first go back to
Lynette? Lynette, may you please repeat your question? Okay, since Lynette is not repeating her question, Galaxy, may you please ask your question? Galaxy.
Hey,
Hello? I can't hear you.
you should repeat all the procedure because I am late. I'm sorry, but you should repeat.
Galaxy, I'm going to request you to ask Mr. Kaziba for the recording after this seminar. I think the entire procedure will be there.
I think that is very fine, Emilia. Thank you so much. Galax, we shall share with you like what Emilia has said. We shall be sharing with you such that you can make a follow-up, and we shall also be sharing her presentation. Emilia, do you have the second question?
Mr. Kaziba?
Yes.
I'm requesting to first answer Abby's question.
Okay, it is okay.
Thank you. Okay, so Abby requested us to redo the tree diagram. I hope Galaxy picks something from this. We say that a certain student school bag contained 4 red pens, 5 blue pens. 2 pens are picked at random from the bag successively without replacement. So we first had a picture of what is in the. We first had a picture of what is in the diagram, the 4 red pens and the 5 blue pens. And we are saying if this student picks a red pen the first time, what would be the probability? Would be the chances of the student picking a red pen the first time? We say that here we shall have your probability being 4, which is the number of red pens in the bag, out of 9, which is the total number of pens in the bag. Because when you add 4 plus 5, you get 9. We then continued to say that now in the bag, since they said without replacement, we have 3 red pens and 5 blue pens. So if this student picks a red pen again, our probability will be 3 out of 8. Since 3 is the number of red pens in the bag currently, and 3 plus 5 gives us 8. So this student has now 8 pens in the bag, since the question said without replacement. I'll then continue. This student now has 2 red pens remaining in the bag and 5 blue pens. But if this student first picks a red pen and then picks a blue pen, we're going to have our probability of picking a blue pen being 5 out of 8. And what will remain in the bag will be 3 red pens and 4 blue pens. But there is also a possibility of this student first picking a blue pen. So you have the blue pen, and the probability of this student picking a blue pen will be 5 out of 9. Will be 5 out of 9. We will then continue that this student will remain with 4 red pens in the bag and 4 blue pens. Since they picked a blue pen, now there is a chance of this student picking a blue pen again. So when they do so, our probability will be 4 out of 8. Since there are 4 blue pens in the bag and the total number of pens in the bag is 8. We'll then continue to have that 4 red pens remain in our bag and 3 blue pens remain in our bag. But there is also a possibility of this child first picking
We're losing up.
I'm very sorry about that. I don't know when I got off. But if this student continues, first picks a blue pen and then picks a red pen, if this student first picks a blue pen and then picks a red pen, we'll have the probability being 4 out of 8 because there are 4 red pens in the bag and the total number of pens in the bag is 8. So the total number of pens that remain in the bag after the student picks a red pen will be 3 red pens and 4 blue pens, and the total number will be 7. Good man. Please ask. Good man. I think we have lost good man. If there are no more questions, I'd like to finish this number at this point. Trinity College. Trinity College. Please unmute.
Repeat again because I've not understood.
What exactly haven't you understood?
Those down like the denominators. I really don't understand.
The denominator is the total number of pens in the bag when you are picking.
Emilia, I think the number is now very fine. Trinity College Nambingo, we shall request, since we want to go into the second number, hope you have understood. Trinity College, you can kindly use the chat. We shall be able to respond since now we want to go to the next number. Thank you. Emilia, do we have a second number?
Yes, I do.
Okay, Emilia, we can go to it. So now when you are preparing yourself, we are waiting for Emilia to share her screen, but please let us practice those numbers of probability and the number of probability and sets. So you must be able to do the number of probability and sets. Probability at times they may ask it as an independent question, and at times they can add it to the one of sets. You may find a set theory number when they're asking you also to find a probability. So please let us be very careful on that part of finding the probability, and also please make sure that by the time we go in for the paper, you're well conversant with replacement and without replacement. And in case we have any other person who was prepared to present, just raise up. We shall give you a chance before we go into the main session, okay?
Okay. Trinity College still goes into session, not understood. What I could say about that number is that probability, when we're learning probability, we were taught that we have probability is equal to the chances of picking what you've, for example, been told. For example, in this case, we're being told about pens. But probability is basically if they tell you, what if you pick 10, you have 10 pens and 5 of them, for example, are blue. What is the probability of you picking a blue pen? So you basically have 10 chances, 10 pens, 10 chances. And in those 10 chances, the chance of you picking a blue pen, there are 5 chances of them. So the denominator comes about in that we're told that the denominator is always the total number of pens or the total number of chances that you have. So I hope that helps you to get the number better. I'll go on to do number 8. One of the number 8s we had, and this one was under the subtopic or topic similarities. So the question said, a birthday cake is in the shape of a cuboid, 10 centimeters long, 6 centimeters wide, 4 centimeters high. The cake is packed in a similar box, 24 centimeters wide. Calculate the surface area of the box. So we shall analyze this question. A birthday cake is in the shape of a cuboid. That's our cake now. Saying that it is 10 centimeters long, 6 centimeters wide, and 4 centimeters high. We shall indicate the 10 centimeters long, 6 centimeters wide, and 4 centimeters high. Then it said the cake is packed in a similar box, 24 centimeters wide. So we are still going to have a similar box, which will now be 24 centimeters wide. So we'll go on to answer the remaining part of the question. This question asked us for the surface area of the box. But for us to find the surface area, we need we're going to need this length, and we're also going to need the height. We'll go on to find those two things in our question. We shall find the linear scale factor in this case. Linear scale factor is got when you compare lengths of different things or when you compare two similar lengths of something. For example, here we're having 2 cuboids. So when I compare this 6 centimeters with this 24 centimeters, since I said a cake is 6 centimeters wide and the box is 24 centimeters wide. So this is the width of our cuboid. So when we compare the two widths, in this case, we can get the linear scale factor. You can also get it when you compare length and height, depending on what you have. In this case, what I have is the width. I have an unknown for the length of our box, which I've called X centimeters. I also have an unknown for the height of our box, which I've gone ahead to call Y centimeters. But before I do anything, I'm going to first find the linear scale factor. So in this case, my linear scale factor is 24 out of 6. Now I'm comparing my width. And this, when you divide 22 by 6, you're going to get 4. So since I compared the box over the cake, when I'm finding the length and the width and the height, I'm going to still compare the box and the cake because that's how I've got my linear scale factor. So I'll go ahead to say that x out of 10 is equal to 4 because when you get the length and the length, you still get linear scale factor. Then I'll say that x is equal to 4 times 10. This gives me x is equal to 40. Therefore, my box is going to be 40 centimeters long. I'll then go on to find the value of y. And in this case, y, which is the height here, out of the 4 for the cake is still equal to 4. So I still have y is equal to 4 times 4, and then y is going to be equal to 16. So the length of that box is still going to be, the height of the box is going to be 16 centimeters. Okay, so I'll go on to the next part of this question. By doing that, I've only answered part of the question. The question went ahead to tell us to calculate the surface area of the box. And really, you have a question? Could you please unmute? Mr. Kaziba? Unruly has no microphone. And I was thinking that you may please help us and you inform him that probably that's why he can't hear us.
Okay.
We can't talk to him either. Thank you. Okay, someone is asking which class is this? This is basically O level, S4 and S3, I think, because they are the ones who are doing this curriculum. So both classes are welcome. I'll go and find the surface area of my box. I have my box there. I now have my width, my length, and height. So to find the surface area of the cuboid, you're going to have 2 into brackets, the length times the width, plus 2 into brackets, length times height, plus 2 into brackets, width times height. Why do we say 2 length times width, 2 length times height, and all that? Now, the length times width is this face down here times, and so we are finding the area for this face down here. But then this face down here is similar to the face we have up here. So they have the same exact area. Therefore, their area, for you to get their area, you could just simply say 2. It's length times width. The same applies for this length. For this length times the height, that face that I've tried to outline out there is the same as the face we have here at the front. Same applying to the width times height, which is the face that I'm outlining out there for you with this one. That's why we say 2 width times height. Okay, so I'll continue. We have our, so we'll have our length being substituted with 40. Where we had width, we shall substitute with 24. And where we had the height, we shall substitute with 16. We'll go on to find that 40 times 24 gives us 960. 40 times 16 gives us 640. While 24 times 16 gives us 384. When I multiply 2 with 960, I get 1,920. Then when I multiply 2 with 640, I get 1,280. When I multiply 2 with 384, I get 768. Well, therefore, when you add all that up, you get 3,968. You do not forget the units, which in this case are centimeters squared, since we are dealing with surface area. Well, that was it for that number. Any questions?
Anyone who might be asking a question?
Bigoli, is unmute. Please go ahead.
The difference between linear scale factor and area scale factor.
Linear scale factor is dealing with basically length, width, height, things that are, how do I say it? Things that are small, like they are basically centimeters. You're not having these centimeters doubled or something. In area scale factor, you're going to deal with areas of different things. You could have surface area of 2 rectangles. That's what you're probably comparing. Area of 2 squares, area of the different shapes they can give us, area of 2 circles, things like that. You could also have it when you're comparing surface areas, still area scale factor. For you to get the area scale factor, you're going to square the linear scale factor. So the two are related in that way, because when you get in the area, you're basically multiplying things that are linear, length and width. That's what you're multiplying in this case to get that linear scale factor. Now, someone asked for the surface area of a cube. A cube has all its sides equal, and therefore it has 6 faces with the same exact measurements. So you're going to have 6 into brackets, the side times the side. Since that's how you find the area of a square, and a cube is basically made up of 6 different squares. Then someone said I didn't get the multiplication part. I do not know which multiplication part you're talking about, because we had the part where I was multiplying the faces 2 into brackets, length times width. I said at that point that a cube has 2 faces with the length and width. I still said that a cube has 2 faces with the length and height. I then also continued to say that a cube has 2 faces with width and height. Is that okay? Are there any other questions? The surface area of a cuboid is what we have just dealt with here. Because our box was a cuboid, they told us it was similar to the cuboid cake that we had earlier. So I think if that's what it is. At this point, I'd like to hand over to Mr. Kaziba, since there are no more questions.
That one looks like your question, Joy.
Will you please unmute?
What about the surface area of a tube?
Okay, we really asked for a surface area of a cube. I think a cube. Okay, let me first relate a cube and a cuboid, like someone has asked. A cube is made up of squares, 6 squares joined together to make one thing, while a cuboid is made up of 6 triangles. In these 6 triangles, we're having each, like you have triangle 1 and 2, they look alike. 3 and 4, they look alike. 4 and 5, they look alike. That's what a cube is, basically. A cuboid is. While a cube is 6 faces looking alike. 1, 2, 3, 4, 5, 6. They all look alike. That's what a cube is. So what we have on our screen is the surface area of a cuboid. While for a cube, you're going to have your surface area being 6 into brackets, side times side. Since side times side is how you find the area of a square, and a cube is made up of squares. So that's what makes the difference.
Okay, thank you so much, Joy, for that wonderful presentation. Thank you so much for preparing to present to us. We are really very, very grateful. Thank you so much. Okay, I'm going to share my screen. Going to share my screen. People, now I'm going to ask you, everyone, to look out for the similar questions that we had during the school time. When you look at those similar questions, at the back, we have all the important mathematics formulas. So all these formulas that we are asking for can be obtained from here. When you look at that document, you'll be able to see the total surface area of a cuboid, surface area of a cube, of an open cone, closed cone, sphere, hemisphere. So everything is here. So that means that you may not need now to look out for anywhere else, but just come here and have that formula with you. So that's where you will be able to get those formulas, the different formulas for the different surfaces. Like she has already told you that a cuboid, the sides are different. For the cube, they have the same length. So the way, if at all you know a square, the cube is like made up of squares that are the same. They have the same length. So that is the cube. That's why its surface area is 6L squared. So that is for it when it comes to a cube. Like when you look at it, it looks, let me just do something like this. I'm not so accurate. So this is something like cube. So when you look at it, you will notice that I have this side. Let me call this side. When you look at this side that is blue, this is L and this is L because they are equal. So the area there is going to be L times L, which gives you L squared. So this side here and its opposite side will give us its area will be L squared. Also this side will be L squared. When you look at another side, let me use green. When you look at this side and this side, also its area is L squared. Plus this one we have said the one of blue, which is also L squared. So this is L squared, then plus L squared, then plus L squared. Then when you look at this downer part and this one up here, also gives you L squared. So plus L squared plus L squared. So which gives us the 6L squared. That's why for the cube, its surface area will be 6L squared. The sides have the same length. They have equal length. So when you get the area of one side of one square, this L and L, its area will give you length times length, which gives you L squared. So this side and its opposite, the one up and the one down, then the one inside and this one. So for it, its surface area will be 6L squared. So, but all the formulas, you are going to be able to get them from here. However, when it comes for a cuboid, they have different length. You find that for it, you are using rectangles. So you have the length, you have the width and the height. So when you find its surface area, you get something of that nature. Okay. Let me ask, is there anyone before we go into the second session? Is there any other person? Lynette, you had a presentation. Are you still on the call? Lynette? Lynette, unmute. Are you able to present? Lynette, unmute.
Yes, teacher.
Are you in a position to present?
I'm not ready. Maybe I could be after the one to present.
Okay. Then that is very fine. Arthur, are you ready? Okay. Now
Teacher?
we are going to go in. Yes?
The thing is, I don't know which questions that have been done. How is it going to be?
Okay. Like you had very many questions. You can present any.
All right.
Okay. So after our presentation, we are going to go into the do session, whereby we shall answer a question and then have an answer. So Lynette, are you coming now, or we first go into this session?
First go into that session.
Okay. So now this session will require you to have a calculator, with you, have a piece of paper, have your book. We are going to be using just 6 minutes. We do a number and then we send the feedback. And the first number we are going to deal with, functions. Like I told you earlier on, that function is one of the numbers that are compulsory, the number that will not miss. So we are going to start, I want us to start with number 11, section B number. And I told that for the section B numbers, you shouldn't use more than 10 minutes. So we are going to use 7 minutes to do it. So look on your screen. Hope everyone can be able to see number 11. We are going to try out this function number. After doing number 11 part A, post your answer in the chat. So when you look at this one, read the question, we are finding A, B, and C. We have to post our answers in the chat, then we shall go into another question. So let us start on number 11. We are going to use just 8 minutes to do it, and then we post the answers in the chat. Hope that is very clear. So after that number, we shall look into another number. So we have done probability. Probably we can, last time we did some vectors. So we are going to look at, we have not done quadratic equations, of which we have to do also. And we have not done some matrices. Oh, last time we did some matrices. So let us first do this number of functions. So look at the number, read through, and we are posting our answers in the next 7 minutes. Let us start. Okay, thank you so much. Is everyone coming up? I'm going to allow you to now be able to unmute. But however, we need to be very organized. Do we have anyone finding challenge with getting A as 4, B as 5, as 6, and C as 25? In case you are getting some challenges, kindly let us know. A is 4. Matilda, you are getting A11. Okay, Matilda has corrected it. Please check out whether that is what you are getting. Check out whether that is what you are getting. Okay, I'm happy, everyone. In case you are finding some challenges, Teacher Colin, please let us check whether that is what everyone is getting. So A, we are getting 4. Okay, very good. B is 6 and C is 25. Very good. Okay. Those who have finished, kindly go to the next number. Okay, someone is saying part 2. So we are going to go through part 2 together. Yes, please.
Can I share my screen, my screen to show you the answer?
Okay, you want to share?
Yes.
Okay, Colin, you can share. And we look at the working. Hope everyone is there. So check out. Now we are working on part B, Roman 1 and Roman 2. Mpera, go on and share your screen. Okay, the rest, let us finish. Okay, thank you so much, Impera. So look at his screen. Those who are finding some challenges with working, that is how he has gotten his answer. Okay, thank you so much, Impera. That is very, very correct. Check out. Hope everyone now is getting that. Okay, thank you, Impera. That is correct. Okay, very good, very good. Okay, this number has been very good. The only thing I want now to emphasize is the last part where they asked us to get the values of X. Please, when it says values, they are expecting you to give them 2 values. And this word is key. They can use the word undefined or meaningless. So whenever you see the word undefined or meaningless, it means that your denominator is equal to 0. So it is just a matter of you equating your denominator for the function to 0 and you get the values. So those who have obtained the values, you are getting your X as 3 and X as -3 or plus -3. Once you give one value, it means that you are going to lose out on the mark. So whenever you get a square root, let us not forget that a square root will yield the 2 answers, a positive and a negative answer. Okay, very good. Unless someone has a challenge, that is when we shall go through that number, but I'm happy everyone is very fine. Okay, we are going to look at another number. Should we go in for vectors? I don't know how many are supporting vectors, but let us first go in and look at what we call the proportions. Number 13. So we are looking at number 13, but the first thing I'll ask you to first do is to first type the equation connecting X and Y. Okay, Ruyonza SS, okay, no, we are not going to go into vectors. Let us go in and look at okay, let us first look at proportions. Let us look at proportions. Let us get the equation that connects X and Y. Feel free to first type that equation in the chat before you continue, such that we can get to know whether it is right or wrong. So feel free to type in the chat that equation that is connecting your X and Y. It is the one that we base on to say that now you are right or you are wrong. Okay. So read the question, understand, and then type in the chat which equation connects X and Y. Okay, thank you so much. I'm seeing the equations. Okay. Okay, Becky, we shall look at vectors, but okay, very good. Oh, Tony, look at that equation. Read it very well. They are telling us that Y partly varies as the square of X. That is the first part. Partly varies as the square of X, and partly varies inversely. And mpera and partly varies inversely as X. So you need to write the two parts very well. So Tony, check out on that equation. That equation is not right. That equation is not right. Okay, Joshua Molinzi, not yet. So the equations that I'm expecting you to write. So I'm saying, so right partly varies inversely. So an inverse relation. Okay, we are going to look at vectors, please, don't mind. Yes, let us first finish the proportional number. So Y partly varies as the square of X. So depending on what you are using, and partly varies inversely as X. So that is the kind of equation I am expecting everyone to have. Thank you so much, Ruyonza School. Very good now. Emily Miyambo, that is very good. Let us now continue and look out for the constants A and B. Look out for the constants A and B, those using K and B, K and D. Let us look out for those constants. So now let us fill in the different values, your value of Y, your value of X, fill in the value of Y and the value of X, such that you can be able to get the value of A and B. So when you get the value of A and B, feel free to type in the chat what you are getting. Thank you so much, Dalton. Okay, I'm seeing some people are getting 3, others are getting 4. Okay, that is good. Hope everyone is 3, 4, 3, 4, 3, 4. Thank you. That is very good. So we are getting our y as 3x squared plus 4 out of x. Thank you so much. That is okay. And oh, B is 3 and okay, this is 24. I don't know. I'm seeing some people are getting 3, others 4. I don't know which one is which. Oh, 3, 24, 3.
3.4.
3.4. 3.4. I think we need to find whether which one is which, because I'm seeing 2 differing answers. Okay, so they told us that when our y is 54, so we shall have 54 is equal to x, which is 4. So I'll have a times 4 squared plus b out of 4. So here I will end up with 54 equaling to 4 squared, which is 16a plus b out of 4. So now this is the first equation I'm forming. Then the second equation will be when y is 24 and x is 2. So I'll have 24 equaling to a times 2 squared plus b out of x, which is 2. So I will end up with 24 equaling to 4a, then plus b out of 2. So this is the second equation. And when you look at them, these are simultaneous equations. So I can first eliminate these 2 I have down here by multiplying through by 2. So when you multiply through by 2, you are not seeing that this one will be 48, this one will be 8a, and here you end up with b. So this is another equation. And then here you can also do the same, multiply through by 4. Hope that is what we did, and simplify the equation. So what are we getting? Okay, so I'm not saying that our A is 3 and our B is 24. So check out very well whether that is what you are getting. A is 3 and B is 24. Anyone who is not getting that, check out on how you have solved the simultaneous equation. That is where the challenge is. Check out on how you have solved that simultaneous equation. That is where you are finding the challenge. I hope that is very fine, because when I look at the second one, I'll have 216. Yes, Ethan? Ethan, unmute.
I've really not understood from the beginning.
Oh, Ethan, from which part? Have you understood how we came up with this equation?
Yes.
Then, Ethan, when you look at our conditions that we are given, are you not seeing that they told us that when y is 54, x is 4? Are you seeing this condition?
Yes.
So Ethan, where there is y, substitute 54. Where there is x, put 4. That is the first condition. So here in the place of y, put 54. Then where you are seeing x, substitute with 4. Is it fine? Ethan, hope it is okay now. Is it fine now?
Yes.
Okay. Someone is asking, how is it 24? Okay, I'm going to try to solve the 2 equations. So these are the 2 equations I'm getting. So I have 48, 216 is equal to 64a plus b. So when I subtract those 2 equations, just using the normal, when you try to subtract the 2 equations, you are not seeing 48 minus 216, 8a minus 64. Hope everyone is calculating. So just calculate this. B and B, they are going to go away, and you are not saying that you are going to get your A here. You remain with 65 and 84 and 48 and 21, which will give us automatically our A as 3. So when you get this A and substitute it where there is 8, you are not saying that you have 48 is equal to 8 times 3, then plus the B. And there, when you work it out, I'm not saying you are getting your B as 24. So please just check out how you have solved the two simultaneous equations. That is where the challenge. Oh, okay. We don't have any other method because the equation is, since we are given two conditions, it yields a simultaneous equation. But here, feel free to use any method of your choice when you are solving. You can use any method that you understand most, either elimination, substitution, matrix. You can use the graphical method, any method that is easier for you, it's what you go with. So do not mind which other method you use. Yes, we agree SS Kamwenge. Unmute. Viguri SS, I'm not getting you clearly. Viguri SS, I'm not getting you clearly. Okay, well, I think we can continue. Viguri, you would have it is okay. So now after getting your value of A and B, substitute back in your equation. Yes? Okay, since we are listening, so I expect that. So this is the final equation you'll be having, and it is where you'll be substituting your x is equal to 3. Okay. Okay, then that is fine. So those people who are getting, I think now looking at it, you are getting your answer. Your answer is 35. So make sure that your y is equal to 35. That is your final answer. Anyone getting 35? That is very, very fine. Okay, so that number was on proportions. And then people requested that we do some bit of vectors. But now the vectors I want us to do is going to be the vectors of section A first. And then we may look at one of section B. It is okay. So now the one of vectors, let us first do this number 6. So for number 6, everyone can be able to do it of section A. Then it is for section B that we shall look on next. But let us first do that number 6 of vector. So for section A, we use 4 minutes. So let us do that one, number 6. Okay. 13, 6.3, 13. Okay. Okay. Type in your answers. Okay, thank you, Mpera. You can look at the screen and see whether that is what you have. So the answer is 13. So kindly check. Oh, Jedida is confused. So those who are confused here, since they have told us to use vectors, just assume you have 2 points. Let me say this is point P and this is point Q. So when they say the distance in vectors, distance is more or less like distance is length. So another word they can use is length. They can use the word size. They can use the word magnitude. So any of those words can be used to mean it. So now that means the first thing you need to obtain is to find out what is the length between point P and Q. Find out what is the displacement vector between P and Q. And we know that the displacement vector between P and Q, in case I have this is my point O to P is like -8, 2. O to Q is 4 and 7. So to get that displacement vector PQ, we shall have OQ. This is O to P and this is O to Q. So to get P to Q, P to Q means start from P and move towards Q. So it means that you have P to O, then O to Q, which will yield OQ minus OP. So this is a very good definition that you need to know, that whenever I have a displacement vector, let me say PQ is the same as OQ minus OP. In case I have a displacement vector AB, it is the same thing like having OB minus OA. In case you have M and A, it's the same thing having ON minus OA. Get the second letter minus the first letter. So your vector O to Q is what you have as 4, 7 minus O to P, which is -8 and 2. And once you subtract 4 minus -8, that one gives us 12. 7 minus 2 will give us the 5. So now to get the length I've told you the same as magnitude, the same as size. You get the square root of x squared plus the y squared. So you end up with 12 squared plus 5 squared. 12 squared is 144 plus the 25, which will yield 169. And at the end, you have 13 units. Hope we have picked something. Okay. Okay, Jedida, I don't know whether you have picked. Lynette, yes? Lynette, unmute.
I wanted to say I'm ready to whatever.
Okay, thank you. So let us first have Lynette present something, and then we shall go back to that session. But those getting 13, that is very fine. Okay. Okay, Lynette, share your screen. Share your screen, Lynette.
I hope everyone able to see the screen.
Yes.
Yes, okay.
Maybe you rotate.
All right. The number I chose is functions. Let's just get it here. And then for people with the questions, let's see.
Seems we are losing out on Asimwe. Are we losing you? Asimwe Linet? Okay. Asimwe, are you ready? Arthur, what about Arthur? Are you ready to take us through?
Yes.
Okay. Arthur, you can take us through first.
Okay. So I have this quadratic equation. So the question says, solve the quadratic equation 3x squared minus 4x minus 7 equals to 0. So we first find the product, which is 3 times 7, which is 21. And after finding 21, we find the factors of 21 that will add up to -4. So we have 1 times 21. Well, we have 21, 2 times 21 also is 3 times 7 also is to 21. So we can change the negatives and alternate them in some way so that we can get -4. So we shall say -7 and +3. So we shall use that. So we shall say 3x squared plus 3x minus 7x minus 7 equals to 0. And we shall factorize and put the 3x outside and put 3x into brackets x plus 1, and this side -7 or minus 7 into brackets x plus 1, which is equals to 0. So we shall get 3x minus 7 and x plus 1, and each of them is equal to 0. And with that, we shall say 3x minus 7 equals to 0, where 7 moves to the right hand side and becomes positive, and then x will be equal to 2.333 recurrent, or 2 on the side. Then x can also be 7 plus x, where the 7 will move to the right hand side and become -7, and that will be, oh sorry, it's meant to be 1. Sorry, it's supposed to be x plus 1 equals to 0, we shall get x is equals to -1. But I think the concept is passed, but past is brought here. Yeah. Any questions? Any questions? I guess there are no questions. Okay, Musa. Musa.
Thank you so much, Arthur. I think it is okay.
Okay.
Excuse me.
Yes, Musa. I think that's Musa.
Yes, but I think x is +1, not -1.
Why? Because when the one moves to the right hand side, it changes signs, and then it becomes a negative. So it becomes -1.
Like before crossing the equal sign, it was already x -1 through the workings.
You mean here?
Yeah.
No, because like when we change this back to this, we're supposed to get this. When we are changing this, we are supposed to get that. So now we say this x 7 into brackets x plus 1. So here we shall get -7x minus 7. But with that you're saying, if this becomes a negative, we shall get a +7 instead of a -7.
Oh, thank you. I get it now.
Okay. All right. I guess yeah. Let me see if there are any other questions.
Thank you, Arthur.
Okay.
Leonza, hope you are ready also to take us to the number. Arthur, do you have any other number or what is that?
I have one more number.
Okay, first finish that one, then we shall have Leonza present.
All right.
Arthur, I'm sorry to interact.
Okay.
But I'm not yet satisfied because on this product, it's 21, not so?
Yeah.
But it's supposed to be -21.
Okay, yeah, it's -21 because this -7 multiplies with this 3. And then we shall have a -21. But to get a -21, we have to use factors. Well, Macha taught me in various ways how to do this number. But now, for example, with what you're saying, this multiplies with this, and then we shall get a -21, which we shall either get any of the two as negatives. You can maybe say it's 7 be a negative. So, no, sorry. This -7 multiplies with this. So that's what we have got here. This leads to this. So now when you go to factors, we either say -1 times -1 or the other. So now here, we want to get something that is going to be equal to -4. So I either say -3 or -7, but now to find out, we want to know the one which gives us -4. So -7, if we make 7 a negative, we shall get and negative 4. So we shall use negative 7. I guess I've solved that, but if it's okay with you now.
Okay.
Okay. So let me go to my next number. My next number is given that m star n equals to a minus n squared plus 3 into brackets m out of n. Find the value of 2 star negative 3 and 2 star negative 3 star negative 2. So we start with the equation which is m into brackets m minus n squared plus 3 into brackets m out of n. So we shall have m as 2 and n as negative 3. So when we put them, when we say 2 plus minus negative 3 squared, we shall have to get 5 squared because 2 plus 3 is 5 and 5 squared is 25. So 3 times 2 out of negative 3, we shall get negative 2. So when we add them, we shall say 25 plus negative 2, I shall get 23. And then part B, we shall use the 23 that we have got to solve part B, and since 2 star negative 3 is 23, we shall do 23 star negative 2. So 23 replaces the 2 star negative 3. So 23 star negative 2 will lead us to 23, which is m, and negative 2, which is n. So 23 minus negative 2 squared. Oh my god, this is supposed to be squared. Supposed to be squared. And also this is supposed to be squared. I forgot to edit that part. So it will become squared plus 3 into brackets 23 out of negative 2. So 25 squared is 625, and 3 times 23 out of negative 2 is negative 69 out of 2, where we shall have 34.5. So we shall say 625 plus 34.5 shall get 659.5. So that's what B was. Yeah, so do we have any questions? Okay, Musa, you have a question?
No, it's okay.
Oh, okay. How about Abigail? Abby?
Yeah, please repeat part A. I've gotten confused.
All right. So in part B,
Part A.
pardon?
Part A.
Part A.
Yeah.
All right. So in part A, you want part A of this number.
Yeah, this number.
All right. So part A is A, which is star 2 star negative 3. That's the number they've given us. And we have m star equals to a minus n into brackets squared plus 3 into brackets m out of n. So now we substitute where 2 is m and negative 3 is n. So we shall say 2 minus negative 3, where 2 minus negative 3 is 5. And when you put that into brackets, we shall get squared. Sorry, when you put that into brackets and put square, we shall get 25. And then we add 3 into brackets 2 out of negative 3, which is 3 times 2 out of negative 3, where we shall get negative 2. And 25, which we shall have gotten from 5 squared, plus negative 2 will lead to 23. Abby, you have something to say?
Yeah, I'm still confused on the third part, whereby 3 is multiplying with a bracket. 3 is
Okay.
multiplying with 2 and negative 3.
So it's like this. So we divide both sides by 3. We divide both numbers by 3. I shall get by 3 here, get negative 1, and by 3 here we get 1. So 2 divided by negative 1, we get negative 2. So is that clear?
Oh yeah, thank you.
Okay. Yeah. So what else? Oh, sorry. So what else is anyone with a number with a question?
Okay, Arthur, can you check on the negative 69 out of negative 2?
Yeah.
Are you noticing something?
Negative.
I don't know how to put those two negatives.
Oh, yeah. I see something. Yeah. Supposed to be positive. SP is negative. Sorry for this. So so I get 629 minus 34.5.
Okay. We are going to end here. Thank you so much for attending. Let me wish you a good day. Thank you. Can we turn on our cameras? How many of you can turn on your cameras? And we see some of you. Some of you have not seen you. Okay. Let me wish you a good evening. Let's meet again. Bye.
Bye.
Have a good evening.
Sorry, I was in another meeting. Sorry about that. Okay,
Excuse me.
let us first have Luyonza. Luyonza, are we on?
Yes.
Yes. Okay. Let us first have Luyonza present a number. Luyonza, you can come on. People who want to do vectors, please, we are going to go into vectors, don't worry. Luyonza.
Hello. We are going to do number 13. Number 13 in paper 2. Can everyone see my screen?
Yes, we can, but the paper is upside down.
Okay, let me sort that.
Rionza, we can let us present like that. It is okay.
Okay.
We shall bear.
So it reads, given that f equals to a squared plus bx, f1 equals 5, and f of 2x, no, sorry, and f of 2 equals to 14. Find the value, Roman number 1, the values of A and B. So we shall first rewrite our equation where it will be saying f of x equals to a x squared plus bx, and our first condition was f of 1 equals to 5, whereby we shall make 5 equate to our above equation of fx, where it will be 5 equals to a times 1. We shall replace the x with 1 times 1 power 2 because our x was squared. Then plus b times 1 because our x equals to 1. So when you get, so there we shall get 5 equals to a plus b, because 1 squared equals to 1. So it will be pardon? Okay, then that was okay. Okay. Please of that. 1 second. Go sharing it your chat.
Can you minimize such that they can be clear? Don't mind, we are going to adjust. Since we are close to Rionza again. Rionza, leave it in that form, don't expand it. We shall be able to bear.
So let me continue from where I had stopped. We have finished the first equation. So we have gone to the second condition where we shall use f of 2 equals to 14. But now we shall replace the 2 with the x. Wherever we shall find x, we shall put there 2. And then equate the equation with 14, where it will be 14 equals to a times 2 squared because our x was squared, then plus b times 2. So we shall get 14 equals to A times 4, because 2 squared you get 4, plus 2B. Then we shall get 14 equals to A, equals to 4A plus 2B. That will be our second equation. As you all see, we have two equations now. Our first equation equals to A plus B equals to 5. And then our second equation is 4A plus 2B equals to 14. For my case, I have chosen to use the matrix method, but you can use any method that you wish to use. That's very simple. So here in this case, we have the first equation where A has the coefficient, so we shall have 1, 1, 4, 2. Then then we shall have another bracket which will be of A, B, which will be equated to 5, 14. Hope you're all with me. So when we continue to the next step, we have our original bracket with our 1, 2, 1, 1, then 4, 2. Then here, when you want to continue, use the adjoint, where you exchange the numbers in the major diagonal and just change the signs in the minor diagonal. Here, our major diagonal, we have 1 and 2, where we shall exchange the 2 with the 1. We put we put 2 in the place of 1, and then put 1 in the place of 2. Then in the minor diagonal, we had 4 and 1. We shall just change their signs. Since they were both positive, both of them shall become negative. Here, when you are multiplying, you use row by column, whereby 1 times 2, you get 2 plus 1 times 4, where we shall get negative 2. Then 1 times negative 1, we get 1, negative 1. Then 1 times 1, you get a 1. Then when you add, you get a 0. Then we shall go to the lower row of our original bracket, where we shall get 4 times 2, where we shall get 8, then a positive 8, then 2 times negative 4, we shall get a negative 8. When you add them, you shall get a 0. And then you do the likewise to the other bracket. If we go back to here where we got the adjoint, we have A and B, then we equate it with our original. We use, hello? Okay, we use our adjoint brackets to and then we resolve it, where we shall get our exact adjoint bracket, and then we begin it, then we multiply it with our equating bracket, whereby we shall have 2, negative 1, negative 4, and times 5, then 14. Where we shall be having, if we go back, we have negative 2 times A, where we shall get negative 2. We shall get the above, we shall get the numbers, equate them with the above number on the other side, where we shall be having A, negative 2 times A, plus 0 times A, equate it with a negative 4, because they are all in the same above sector, where we shall have negative 2 divided equals to negative 4. So if we want to remain with only A, we shall divide negative 2 on either sides, where we shall have our A equivalent to equaling to 2. Hope you're all with me there. So let's go to B. Let's look for B. So B, we've already said that we equate the above with the above. So here we shall also equate the lower figures with the lower number, where we shall be having negative 2b equivalent to negative 6. If we want to remain with only b, we shall divide negative 2 on either sides, where we shall be having b equals to 3, where we shall replace our real values in the given equation, whereby it will be f of x equals to 2, the value of a, times 2 times x squared plus 3x. So if we move on to the second Roman, they are telling us that find the value of f of 3. So we shall have our original equation, where we shall have our original fraction, where we have if f of 3 equals to 2 times, wherever we had our x, we shall replace it with a 3. So it will be 2 times 3 power 2 plus 3 times our original 3, which we are given. So it will be 2 times 9, which will be 18, plus 3 times 3, that is 9. When you add those, you get 27. That is the first section of this number. So if we move on to B, let me read for you the question as I'm setting the number to be worked on. They're telling us given that f of x equals to px plus 7 and g inverse of x equals to 5 minus 2x divided by 3, find a g of x. Hope everyone has had the question. So let me show you how it's done. Roman 1 of B. So we have our original equation, where we have g inverse of x equals to 5 minus 2x divided by 3. We shall let this very equation equal to m. That's the unknown that I've chosen. So if we say m equals to 5 minus 2x divided by 3, our main aim here is to make x the subject of the formula. So we shall multiply 3 on either side and get 3m equaling to 5 minus 2x, where it shall be, where if we correct like terms, so that we can only use 2x, we shall have 3m minus equivalent to minus 2x. Our main aim, I still emphasize, is only to get the subject of the formula as x, where we shall divide negative 2 on either sides and get our x equivalent to 3m minus 5 divided by negative 2. Since we've got our x as equivalent to that, so therefore our g of x will be, in the place of m, we shall replace it with x, because in our brackets we have x. So it shall be 3x minus 5 divided by negative 2. That was B, Roman 1. So we B Roman 2. B Roman 2, let me read the question. Find the value of P for which G into x plus 3 is equal to f of x. P. So as our question is saying, G of x minus 3 is equal to f of x. And we have already found out that G of x is equivalent to 3x minus 5 divided by 2. So here, G of 2x minus 3, wherever we shall find our x in the previous fraction, we shall put there this very number that we have given in our brackets. So we shall have 3 into 2x minus 3, brackets, close the brackets, then minus 5. You divide everything by negative. Then we shall equate it with our fraction of f of x. F of x is, from our question, it is px plus 7. But so we shall equate both equations because that's what the equation is telling us. Then we shall multiply 2 on either side so that we can remove the fractions. Well, we shall have 3 into 2x minus 3 minus 5 equals to negative 2 tie into px plus 7. Now our aim here shall be opening the bracket first, where it shall be 3 times 2x, where we shall get 6x, then 3 times negative 9 times negative 3, you get negative 9, then minus 5, equaling to negative 2 px, because we've multiplied both, then negative 2 times 7, you get a negative 14. So here we shall add the negative 9 minus 5, and we shall get a negative 14. So 6x minus 14 equals to negative px minus 14. Negative 2p minus 14. Then we shall collect like terms and make the unknowns to one side and then leave the knowns to the other side, where we shall get 6x plus 2px equals to 0, because this side we had a negative 14, then the other negative 14, when it crossed the equal signs, it became a positive. When a positive with a positive and the negative, you get a 0. So here, our question is saying we should get the value of p, where we shall first pull out the common factors in this equation. Our common factor is 2x. Then we shall remain with 3 from the 6x, then plus a p, because 2x has been taken away from 2px. Then we shall equate it with our 0. Our main purpose was to find the value of p. But since we have our equation as a multiplication equation, we shall just find the value of P, where we shall get 3 plus P equated to 0, where we shall have P when 3 crosses the equal signs, it becomes a negative. That's my presentation, and the number has ended. Is there any question or anything that you've not understood?
Raise up your hand in case there is something. Yes.
Buguli? Buguli? Is there any question? If there is no other.
Okay. I think we may not be having any questions. I want to thank Luyonza SS. Thank you so much for that wonderful presentation. Thank you so much. Thank you so much for presenting. We really appreciate your efforts, and also we appreciate the teacher for preparing you and your fellow students. Thank you so much. Okay. Unless there's anyone with any presentation, but maybe I want to, Biguli SS, seems you have a question.
To be displayed scanning.
Yes, Lynette.
I have a presentation.
Okay. Okay, Lynette, take us through. Do you answer this? You have another question?
No, I'm just sharing for that one that wanted the question.
Oh, okay.
I hope everyone is seeing the screen. Hello. Hello.
Yes, continue.
Okay, I'm doing number 9. A triangle ABC whose area is 12 centimeters squared undergoes a transformation represented by T is equal to 1, 3, negative 1, 2, which maps onto A prime, B prime, C prime, and they want us to determine the area of the image, A prime, B prime, and C prime. So the transformation matrix given is 1, 3, negative 1, 2. Okay, when you're finding this, you first find the determinant of the matrix. And you know, to get the determinant is major diagonal minus minor diagonal. And in this case, our major diagonal in the matrix T will be 1 times 2. Like the values in the major diagonal are 1 and 2. And the values in the minor diagonal are 3 and negative 1. So that's why here, where I'm finding the determinant, it's 1 times 2 major diagonal minus 3 times -1, which is minor diagonal. And then our answer is equal to 5. But the reason as why I put these lines that as if show magnitude are because in this kind of thing, the determinant you should get should be a positive. So even if I had found my 5 as -5, these lines that are enclosing the determinant still show that that 5 should be a positive because there's no area that's negative. Yes. So after that, our determinant is equal to, our determinant that's a positive, okay, is equal to area of the image out of area of the object. And in our question, if we are to read, a triangle ABC whose area is 12 centimeters squared. So that's the area of the object. And I want us to determine the area of the image. I hope you're following. Yes, so the area of the image, which we don't know, I would assume it to be X. So let the area of the image be X. And then the determinant we got, which is 5, will equal to area of image out of area of object, i.e. the area of the image, which is X, out of the area of the object, which is 12. And then after that, we shall cross multiply. Okay, 5, we know 5 has that silence out of 1. So 5 times 12, if I'm to cross multiply, will be equal to X times 1. And in this case, X times 1 is 6. So X will equal to 5 times 12, and X will equal to 60 centimeters squared. Remember, we let our X be the area of the image. So the area of the image, A prime, B prime, and C prime is 60 centimeters squared. Yes. That is it. Thank you for listening.
Okay, thank you so much. Okay, hope everyone can be able to see the question here. Okay, those asking for the questions, we are going to share them again on the WhatsApp group. Okay, thank you so much, Lynette.
You're welcome.
Okay. Okay, then lastly, can we have Emilia Joy present something also? Joy, are you on? Okay.
Thank you, Mr. Kaziwa. So I'm going to be sharing on a number, which is an equation of the line. It was in one of the mock examinations were given. It was a number 8. This question said, find the equation of the line that passes through the point A, -1, 2, and is parallel to the line 2y plus 4y is equal to 9. First of all, parallel lines, what we have to note is that parallel lines have the same gradient. So in this case, and we know that the general equation of a line is y is equal to mx plus c. In this case, m is the gradient. So as we look at our equation that we've been given, I'm going to put it in the format of y is equal to mx plus c, so that we can get the gradient, so that we can get the gradient of this line and the line, it is parallel to. Therefore, shall have 2y plus 4x being equal to 9. From there, we shall have the 4x being subtracted from the 9, as the rules say. When you have a positive here, when it crosses the equal signs, it's going to become a negative. From there, we shall divide by 2 on both sides. So when we divide by 2 on this side, we shall have y being equal to 9 out of 2 minus 4x out of 2. We'll continue to say that 9 out of 2 gives us 4.5, while 4x out of 2 gives us negative 2x. We shall put this equation in the format of y is equal to mx plus c, and our equation will be y is equal to negative 2x plus 4.5. So since we say that the number that is here right before the x is the m, which is our gradient, which is m, will therefore be equal to negative 2. So from that, we have found the gradient of the line of the equation of the line we are finding. So from there, we shall go ahead to have our own equation where we are now finding point C. Since our question told us that this line goes through a point A, negative 1, 2, that means that we are going to use this point to substitute into this equation, and we shall therefore find C. So this is a value, negative 1 is a value for x, and 2 is a value for y, because when we are starting coordinates, we state the x coordinate and then the y coordinate. Therefore, we shall have 2, we're now substituting the 2 for the y, is equal to the negative 2 times this x, now negative 1, plus c. When you multiply a negative and a negative, you get a positive. So we'll have 2 is equal to 2 plus c. When you take the 2 onto the other side, we shall have 2 minus 2 being equal to c. So our c, when you have 2 minus 2, it gives us 0. So our c will be equal to 0. We'll look back at our equation of y is equal to mx plus c. We now know that the gradient is negative 2, and c, in this case, is 0. So we'll substitute those two values, and we'll have y is equal to negative 2x plus 0. You adding 0 and not adding 0 is the same, so our equation will therefore be y is equal to negative 2x. Someone said supposing it's perpendicular. If they say that and is perpendicular, for example, that part where it says parallel, and is perpendicular to the line 2y plus 4x minus 1, would get the gradient of the line, and after getting the gradient of that line, would go ahead to say that m1 times m2 is going to be equal to negative 1. So that's how we'll find the gradient for the second line. We'll then say that in this case our gradient was negative 2. So we'll say negative 2 m2, because when you multiply times m2, it's going to be negative 2 m2 is equal to negative 1. So divide by negative 2 and also divide this side by negative 2. So in that case, if they were perpendicular, the gradient of the second line would have been equal to half. There are any questions that you'd like to be answered? Mr. Kaziba?
Yes, Emily.
Since there are no questions, I would like to end my presentation here.
Okay, have you answered the one who was asking about perpendicular?
Yes, I have.
Okay, thank you so much. Thank you so much, everyone. Someone had the number I want us to do is going to be a number on vectors, but I understand there are students who do not do vectors at all completely. Yes, many those of section B. So I feel we are going to do it. We are going to do a number of vectors such that at least we go out, such that when everyone is contented. So let me check out on that number of vectors of section B. We are going to just summarize it. I don't know which number we can choose. In paper 2, last time we did at least a number on vectors, but probably we are going to just summarize some key things in vectors. But for section A, feel free to prepare for it. Emilia Joy, did you do this one?
Yes, teacher, I did.
Okay, I think this is the one we did last time. So we have this one. And also we have the one that is not in Word. So I think we can do any. We can try out any. But we are going to just summarize it. Do we have anyone who wants to discuss for us this? Anyone who wants to take us through this? Okay, we are going to just summarize it. So when you look at our screen, we have in the triangle OPQ. This is the triangle O, P, and Q. O to P is P. So this is O to P is P. So P is there. O to Q is Q. Q is here. O to Q. And then O to S. O to S is a third of OP. A third of OP. OR is a third of Q. And point T is on QS, like that. And what do they want us to obtain? One, they want us to obtain first S to R. So when they tell us that they want us to get S to R, it means that your starting point is S and you are moving towards R. So this is where S is and I'm moving towards R. So when I have S to R, always I will look out for the shortcut. I'll look out for the path that can make me move from S towards R. So when you look at S and R, I have very many routes I can use. But what matters a lot is, do you have everything that, depending on the route you are choosing, do you have everything? So the first route I have, I can move from S, I come towards O. So that route is, I'm going to call it S, O, plus from O, I can move towards R. So that is O to R. That is one path. Another path you can use to move from S to R, I can move from S to R. So I can move from S to P, then from P, I move towards R. That one is also K. But always you keep in mind asking yourself, do I have that route? Another route you could use, you could move from S to P, P to Q, and then Q to R. But always avoid using longer routes because they may lead you to making mistakes. Then, which route is the best to use? Now, when I look at the second route, this one is SP. We can obtain SP, but we have P to T, which P to T we have not yet obtained, and is one of the things they want us to get. So meaning that that path may not work for for us. So what am I going to do? I'm going to use S to O. Then you ask yourself, what is S to O? When I come here, they are telling us that O to S is a root, is the same as a third O to P. Then you ask yourself, what is O to P? OP is the same as vector P. So meaning that OS is a third P. So O to S means that I move from O to S. So in case I want to move S to O, in case I change the direction and I want to move from S to O, it means that now I am also going to change the vector. So when I change any vector, when you are changing the direction of a vector, we use a negative. A negative shows a change in the direction. So meaning S to O, I'll have negative a third of P. This negative shows me that I have changed the direction. Initially it was O to S and we had a third P. Since now I'm changing the direction to move from S to O, then I'll have the negative a third P. Then we want to get O to R. When you look here, we have O to R. They are telling us that O to R is the same as a third O to Q. So what is our OQ? OQ is the same as Q. So meaning we shall have a third Q. So these are the two expressions that we want. So I'll come here and I say S to O is negative a third P plus a third of Q. When you want, you can write it much better. So I can write it as a third of Q minus a third of P. Since a third is the common factor, I can pull it out and I say, this is a third of Q minus P. So that is our vector S to R. Okay. Then the next vector they are asking us to get, they're asking us to get Q to S. So when you look at vector Q to S, I can first remove this. Q to S means that I'm going to start from, remember the starting point is very, very important, paramount. So we want Q to S. So this is our vector Q, and this is S. So in other words, even I can try to draw something to show what I really want. So that is my vector Q to S. So when I'm moving from Q to S, you ask yourself, what is the starting point? So my starting point, it means if at all I want Q to S, I will start from Q, I move towards S. So now I will say that Q to S, it means I will move from Q, I come towards P, I say QP, plus I move from P, I come towards S. That is one route you can use. Another person may say, I may use another route. Instead of using, yes, please.
Why is it that I cannot just come QO2 plus OS?
Okay, that I'm coming. I'm saying there are very many routes you can use. That is the second route I'm doing. So Q to S, I can come from Q, I come towards O, I say Q to O, plus from O to S. That is the second route. But always I've told you, look out for the cheapest, for the simplest route for you to use. It doesn't matter. But in case you have any of those variables, but you need to first look out which one is easy for you to use. So now when you look at the routes we have so far two routes. Now, another person could as well even say, I can move from Q to R, R to S. It is also K, but look out for the easiest one. Now, when you look at the first one, Q to P, you ask yourself, do I have Q to P already that I have not yet obtained it? Then I ask, do I have PS that I don't have PS? Meaning that this route is possible, but it's not the simplest. Then I go to the second. The second one we have QS is Q to O plus O to S. Do I have Q to O? That yes. Do I have O to S? That yes. So that is the easiest route for you to use. But what do you need to know? That we have O to Q, that our O to Q is equal to Q. Meaning that if at all they want me to get Q to O, it means that now I'm reversing the direction. So meaning to reverse, we said you bring a negative. So Q to O will be negative Q. Then what about O to S? O to S, they have already told us, is a third of O to P. Good enough, I have OP already. So meaning I will say a third of OP, which is P. So that is now what I have. So I'll just come here and I say my Q to O is negative Q plus a third of P. I can write it in a very good way, in a better way, by beginning with a positive and then I go to the negative. So meaning that now you can write it as a third of P minus Q. If at all you want, continue. Find the LCM, which is 3. So I can write it as 3 P minus 3 Q, which I can write it in a very good way as a third into P minus 3Q. So that is your vector QS. Okay, hope we are together. Then the next one I have, okay. The next vector I have is going to be, let me first remove this. Okay, the next vector I'm going to have is going to be P to T. So P to T, look out for the possible roots we can use. Anyone to give us, in case I want to get P to T. Remember they told us that and point T is on QS. So assuming this is where our T is on QS. So let me first draw, this is our QS and this is where point T is. So who can give us how this, which root can you get PT? Yes? Anyone?
P2 plus T.
Plus?
We use P2 plus QT.
Oh, sorry about the bubble. You are saying P2 we use?
We use P2 plus QT.
We use P2, we use PQ plus QT. Very good. Hope everyone can see that root. PT is equal to, P to T means we start from P, we move towards T. So I can move from P towards Q. So that is PQ plus QT. Very good. That is one path. Which other path? Any other person to give us any other path you see that we can use? Yes, Musa? P to T.
P to T, we can use PO plus OQ plus QT.
OQ,
plus QT.
Continue. Plus QT. Very good. O to Q, then Q to T. All those ones are correct paths. Now the next question you are going to ask yourself, which one, when I look at all those roots, which one, where do I have everything that will be the same? So we start the first one, P to T. Do I have PQ already? That I have not yet gotten PQ. Then, do I have QT? Yes, it can be obtained. So allow me to write on a bigger, I'm going to, let me go on a bigger board to write this. Okay. Just give me a minute. I want to check to go to the bigger board such that we write those two parts. Just give me a minute. I want to go to the something very big as I look out for these questions. Okay. So, but we can try both methods, all of them yield the same answers. So allow me to draw that simple triangle here. Okay, sorry. Okay, so we are going to first look at it is PQ plus QT. Okay, so we are going to use both. Okay, just give me a minute. I want to draw it on a bigger space. Okay, so this is O, this is P, this is S. We are placing our T somewhere here, and this is R, this is Q. So the first part that we are going to use to get our P to T was, someone told us we use P to Q, then plus Q to T. So now, when you look here, we don't have PQ. So meaning you are going to first get P to Q. So to get PQ, it means I can move from P to O. I can say P to O plus O to Q. Then what is my P to O? What is our vector PO? Feel free to type in the chat. What is your vector PO? PO.
Negative.
That is what I want to know. What you are getting for your vector PO. Our OP is P. What about PO? What is vector PO? Okay, negative P. Very good. It is negative P. Good. Okay, so P to O, because they told us that O to P is equal to P. That is when I'm moving from O to P. So when I'm reversing P to O, I move in a reverse order. So P to O will be negative P. So I'll have negative P plus O to Q, which was given as Q, meaning that P to Q is Q minus P. That is our vector PQ. Okay, then do I have QT? That yes. They told us that QT, when you look at the question, QT is the same as 3/4 of QS. So now I'll come and I say that QT is 3/4 of QS. But do we have QS? That yes, that we got our QS as, I'll come back here and I pick it from here. QS was a third P minus 3Q. A third, so a third P minus 3Q. So I'll come here where there is QS, I substitute this, I'll get 3/4 times 1 out of 3, P minus 3Q. So this and this will reduce, so it remain into 1 times 1 out of 4 into P minus 3Q. So this is my vector QT. Then I'll continue and I'll continue. Oh, sorry. So I'll continue and I substitute in my different vectors. So I'll have my P to T equaling to PQ, which is Q minus P, then plus my QT, which is 1/4 into P minus 3Q. So I'm going to collect like terms. So I'll have Q minus P plus 1/4 P minus 3/4 of Q. So when I add, I'll have Q minus 3/4 of Q, then plus 1/4 P minus P. So I'll end up with, this is going to be 1 out of 4Q, and then this one is going to be minus 3 out of 4P. And when you look at it, the common factor is 1/4. I remain with Q minus 3P. Hope we are together on that point. Is that point okay?
Yes.
Okay. Okay. We are fine. Then that was the first route. Another person told us that when we want to get P to T, I can move from P to O plus O to Q plus Q to T. Also very fine. So P to O, we have our answer as negative P plus we want O to Q. We have OQ is Q plus Q to T. Q to T, which we have as a quarter P minus 3Q. So when you look at it, ideally you are going to get the same answer as a quarter Q minus 3P. So when you work it out, you can notice that it is the same expression we have here. So that is how you get it. Then the last one, the last part is getting T to R. This is T and this is R. So which parts can we use when you look at our T and R? Can we give some suggestions? Look at T and R. How can we get T and R? T and R. Someone, you can feel free to raise up your hand and tell us which roots can we use to get T to R. T to R. Okay, yes, very good. Yes, Talent.
We can get TP plus OP.
We can get TP
can get TP plus
TP
PO
plus PO
plus OR.
Plus OR. Thank you so much. Another person. Thank you, Talent. Another person, I say a hand. Yes, Musa. Musa?
Sorry, sir.
Okay, it is the same thing?
Yes.
Okay. Yes, so someone can move to get where you want. You can move any path. I told you any path to use. So T to R, from T to R, I can move from this. I come here and I come here. Or someone could move from T to Q, Q to R. That one is also key. But as long as you have those different things, so you can use any of those parts. So when I decide to use the first one, T to P, we have our answer of, but we have PT. We have PT as, so our PT is a quarter Q minus 3P. Meaning that if at all I want to get T to P, I'll get the negative. So I'll say negative a quarter of Q minus 3P. So when we enter this negative, this Q becomes a negative, this negative becomes a positive. So I can have a quarter into 3P minus Q. So that is your TP. So I shall say TP is going to be a quarter 3P minus Q plus PO, which we have as negative P, plus O to R. So when you look at your OR, I don't know whether we have OR already. OR, they told us is a third of OQ, which is a third Q. So I'll come here and I add our OR as a third of Q. So I open up the brackets, I get 3/4 P minus 1 out of quarter Q minus P plus a third of Q. Then I'll collect like terms with P's. So I'll have 3/4 P minus P minus a quarter Q plus a third of Q. So when you try to solve for 3/4 P minus P, this one will give us negative 1 out of 4P. Then when you have negative a quarter plus a third of Q, you end up with that is going to be 1 out of 12 12Q. Hope those are the answers you are also getting. Confirm. So when I write it much better, I can write it as 1 out of 12Q minus a quarter P. So when you look at it, you can get your LCM here. Your LCM here will be, you can use the 12. So you can have the 12, and here you have the Q minus, this is going to be 3P, and you end up with your answer as 1 out of 12 into Q minus 3P. Okay, hope it is clear. Ruyonza is saying we use TS, SOR. Yes, that is also very fine. So, Ruyonza, they want us to get TR. They want us to use TO plus, let me check the chart, TO plus O. SO. Okay, now Ruyonza, this part may not work for us. Look at it very well. You are saying to move to get TR. So you look at the path, we want TR. Now, when you say TS, TS is here, good. SO, good. And OR. Yes, perfect. It works well. Thank you, Ruyonza. Also, that works very well. Yes. So you use any path that you want. Another person could say TQ plus QR. Also, that one works. So feel free always to use which one is easier for you. The one that will give you an answer very easily. So that is how you get your answer, I think, for TR. Then the last one is the tricky one where they ask for collinearity. So when they ask you to get collinearity, is the one that usually fails most of the students. But there you just look out for one thing, that two vectors are collinear if they lie on the same line or when they are parallel lines. That is what we call collinearity. That two vectors are collinear, or they say P, T, and R are collinear if they lie on the same line. So the moment you hear the word collinearity, it means that those things lie on the same line. So that is what you want to prove. So when you look at what they have given us, they are giving us P, T, and R. So here, it means that you are going to create two vectors that have a common point. So last time I remember, Emilia Joy took us through this, how to get collinearity. So I want us to look at P, T, and R. Look at P, T, and R, and we formulate the two vectors we can use. Feel free to raise up your hand. I don't know whether Joy is still on the call. So we have P, T, and R. Can we create two vectors we can use? It would be much better to use even what we have already here. Someone can start. Which vectors can we use to show that they are collinear? P, T, and R. Feel free to raise up your hand. Anyone? Yes, Bigulia says. Bigulia says, I'm not getting you. Abby, Bigulia says, seems your network is not so clear.
Could use PT and TR.
We can use PT and
TR.
And PR, good. So we can say that PT is equal to KPR, where K is a scalar. That is very okay. Yes. So the question you ask, do I have PT? That yes. Can I be able to get PR? That yes. I don't know whether it is clear. Hope that is clear. PT and T.
What about TR? PT and
TR, PT and
PT, TR.
PT and
TR.
And PR. PT and PR.
Part 3 and part 4. PT and TR. The T.
PT
and T
and TR.
Yeah, that one.
This one. This one may not work for you, but we need to try it out. We need to try it out, whether it brings out the collinearity. But what you need to know that when it comes to collinearity, if at all this is my line, P, I have Q here, and I have R here. To show collinearity, just get one point and a starting point. Let me say I start with P. It means I can say P to Q should equal to the scalar of PR. PQ and this vector of PR. This is what we call the collinearity. That they are parallel vectors and that they lie on the same line. So this is the simple way of proving collinearity. So now for our case, where we have those two, that is what we do. So just look out. We may not go deep into it, but just look out for your vector PT and look out for PR. The good thing, we have PT already here, and then we have PR, we don't have it, but you can easily obtain it. That P to R, from P to R, you can use any path. You can say PO to OR. I don't know, do we need to do it?
Yes.
Or you'll be able to complete? Shall we be able to complete? Yes?
You can try it.
We do it, eh? Okay. So we are going to say PT is equal to the scalar of P to R. So now we are going to first find PR, and we have said that to get our P to R, I remove from P to O. So I will say PR is going to be PO plus O to R. Hope that is it. Plus O to R. So I'll come here again and I get O to R. So P to O is negative P plus OR. OR, I remember, was it a third of OQ? Hope that is it. We should be very sure. Okay. OR is a third of OQ. So that is now your expression. Then when you look at your P to T, our P to T, let me look for it here. PT was a quarter, Q minus 3P. It was a quarter, is it P minus 3Q? A quarter Q minus 3P, a quarter Q minus 3P. So I can still come and I write this vector in a good way as I can get the LCM, which is 3, and then I'll have negative 3P plus Q, which you can write again in the form of a third into Q minus 3P. So this is your P to R. So what does it mean? It means that now our PT is equal to a scalar K of PR. So vector PT, we have it as a quarter Q minus 3P, which is equal to K, P to R, which is a third of Q minus 3P. So in simple terms, I don't want to say that they are crossing, but vectors in the same direction, so you equate them. So when you look at this expression and this expression, you are not seeing that they are the same. So meaning that our quarter is equal to k out of 3, and your k is the same as when you cross multiply, you'll find that k is 3 out of 4. And therefore, it means that pt is equal to 3/4 of PR. So that is how we prove that two vectors are collinear. Hope that is fine. Okay. Then degree SS, they're asking, can we, or what about when we use PT to TR? Okay, we can do it. So we have, what about when we add PT to TR? Okay, now PT, what is our PT? PT, we have it, I think so. Let me just confirm that PT is there. Okay, PT, we have it, and then meaning we are going to find it, okay, even TR. So when you look at PT, I think PT, we have it as 1/4 into Q minus 3P. Then what about TR? TR, we got our answer as 1 out of 12 Q minus. We have 1 out of 12 Q minus 3P. 1 out of Q minus 3P. Q minus 3P. And actually, when you look at this and this, you notice that they are the same, meaning 1/4. Let me just put here my K. So in case I have my K here, it means I'll have K times 1 out of 12. And when I cross multiply, I'll have 12 out of 4 equaling to K. So meaning that by 4, 1 by 3, and my K will equal to 3. So PT gives us, that is 3 of T of R. Yes, however, when it comes to collinearity, the best way, what you have to ensure that there is a common point. You have to ensure that there is always a common point. And whenever there is a common point, it is always better that you have the same starting point. But in case I have P, Q, and R, it means that when I have P as my starting point, it means I have PQ and P to R. So this letter that is starting has to ensure that it is the same like that. In case you had decided to start with, let me say, R, you can now have R to Q is equal to, R to Q is equal to K of R to P. So that is when you get the very right answer. So the starting point here on both vectors is very crucial. Okay, let me hope that is enough. That is enough for now. Allow me that we end here unless someone has a question on vectors. But vectors, go for it when you are very sure and when you are very, very strong at it. Make sure you make a lot of practice in order for you to be able to attempt that number concerning vectors. Otherwise, thank you so much for attending. We are going to see how we are going to be handled next week. I thought, yes? I thought that maybe my thinking was that most of you are going back to school this weekend, but they're telling me that some of you are not going back this weekend. I don't know, by show of hands, how many are returning to school this weekend, Saturday or Sunday? Okay, it is only one person, meaning the rest are still here. Okay, so we are going to see how we are going to plan, but in case of any program, then we are going to let you know how we shall be linking up. Okay, Lyonza, they are already at school. Okay, that is good. We are going to see how we are going to be linking up. If at all it goes on well, this evening we shall be sending you some mock papers for you to try out and their marking guides. So please check on the WhatsApp. We have already shared the worksheet and the marking guide for some few papers, but we promise we shall share also the rest very, very soon. So let us keep active on the WhatsApp. If anyone can pick the link, I'm saying some people are not yet on the WhatsApp, but in case someone can pick for them the link, I don't know how possible it is, but let me see for those who are not yet on the WhatsApp, whether we can pick the link, but we can have someone. Matilda, I'm going to share the link, but we can have a volunteer. I want to thank all the teachers that have been on the call. Teacher from Degree SS and your colleague, Teacher Collins, engineer from Lyonza SS. Thank you so much for attending. I don't know whether Teacher Collins and the teacher from Lyonza, whether you have any word, you could unmute and say something. Lyonza SS, are you with your teacher? And Degree SS? Okay, okay.
Yes, Mr. Kasbamarom.
Okay, Teacher Colin, can you say something?
Good evening to everyone. So we have been on and off in the session. I left students alone, but I really want to thank you, Mr. Kazuba, for this arrangement. We have actually been active for this holiday, and we believe and I encourage students that they shall always put into practice what you have always been discussing for them. We are really much grateful at your session. I know you're doing very much work and you're always busy, but for sparing such a time and you gather with us. I encourage students that they shall take on these questions as they go back to school, and their respective teachers will always guide them where they need to be. Thank you. I wish you a nice evening, students.
Thank you so much, Teacher Collins. Please, make with the questions to school. Yes, Teacher Kenneth from Lyonza. Engineer. Lyonza. Are we failing to get in? Lyonza School. Oh, it seems we are failing. You can unmute. Okay. It's okay now?
Yes. Yeah, Mr. Kazuba. The achieving, because we are achieving all this, and even gaining more experience presenting these questions. So appreciate you can have a load, and even in other subjects, because not only in these compulsory subjects, but if we can get other optional subjects, and it can be okay. So thank you, sir.
so much. Thank you so much. We shall try our best. Those on the WhatsApp group, I shared some history seminar questions for South Africa. Those seminar questions are really very good. Please check them out. Also shared some history South Africa, history East Africa, and it had a lot. It had a lot. The summarized points and everything. So please make sure that you have that pamphlet to help you in revising history, such that we know in history we have already secured our distinction and also in other science subjects. But we shall be sharing a lot. Maybe next week, if things go on well, we shall see how we can have an English seminar. We shall also see how we can have a geography seminar. Probably, God willing, we shall also have the physics seminar next week. But we are going to first look at our programs and then we see what is possible. Otherwise, I want to thank you so much for attending. Thank you so much for sacrificing. You have used a lot of data to be able to attend, and I pray that the Almighty God blesses you, that you pass with only first grades. We are looking for only first grades, and we shall be happy to celebrate with you come next year, February. Can we have any volunteer to lead us in a word of prayer? Yes, thank you so much, Teacher Kenneth. Any volunteer wants to lead us in a word of prayer? Okay, yes, Talent.
Loving Majesty, we take this honor, we take this opportunity to say thank you. Thank you, our Lord Almighty God, you have guided us through this seminar. Father, we pray that everything we have learned, we put it in our, Father, we get it into our heads, Almighty Jesus, and help us so that everything we revise, Almighty God, we get it, Father, King of Kings. After passing with flying colors, we're going to glorify your name. We have prayed through your name. Amen.
Thank you so much, everyone. Bye-bye. Let us meet next week, and we want to wish success going back to school.
So we meet.